Hello and welcome to our integrated project animated video, where we'll be explaining the solutions to the tasks assigned to us. I'm Farhan.
I'm Chin Hua.
I'm Nisha.
I'm Farah.
Now, let's get started. Task A. Calculate the speed of the submarine when surfaced and submerged in knots or kilometer per hour. This is the schematic diagram of the submarine design. So, the assumptions made for this task are steady flow system, kinetic energy and potential energy are negligible, width equal to height equals to diameter, which is 12 meter, density of seawater at surface and depth of 240 meter are equals to 1025 kg per meter cube. Dynamic viscosity of seawater is equals to 0.0011 kg per meter second. Power generated by turbine is fully transferred to propeller and number of blade on propeller is equals to 8. Right, to solve the question, we are required to use this speed equation which are already derived. We're going to declare the speed as V submerged. So, V submerged is equals to bracket 8 multiply power required over pi times density times diameter squared close bracket to the power of 1 2/3. By substituting all the calculated values of the variables into the equation, we will be getting V submerged equals to 14.365 knots. Next, to find the net thrust generated by 8 blades propeller when the submarine is submerged, we'll be using this equation, the net thrust equation. So, the net thrust is equals to thrust minus the total resistance faced by the submarine. As always, we need to substitute all the calculated values of the variables into the equation to solve the problem. In this case, the calculated values of thrust is 3.562 meganewton and the total resistance is 0.308 meganewton. By substituting both values, the net thrust produced is equals to 3.254 meganewton.
To calculate the speed of the submarine when surfaced, we will be using the derived speed equation, which is V surface is equal to coefficient of speed of the submarine when surfaced times the speed of the submarine when submerged. By substituting both of the variables, V surface is equal to 7.89 knots. Next, to calculate the net thrust generated by 8 blades propeller when the submarine is surfaced, we will also be using this net thrust equation where net thrust is equal to thrust minus total resistance faced by the submarine. We shall then substitute all the calculated values into the net thrust equation and simply solve it to get a value of 3.462 meganewton.
For task B, it is required to determine the amount of heat transfer required to reduce about 70% of the reactor output heat. This is the schematic diagram of the heat exchanger designed. The assumptions made for this task are: the diameter of the heat exchanger tube is 19 mm, the length of the heat exchanger is 6 meter, and the fluid used is water. Hot water from the reactor is cooled down from 330 to 295 degrees C for the tube part, and cold water from the cooling system is heated from 260 to 280 degrees C for the shell part. The overall coefficient for heat exchanger is 2000 watt per meter squared degree C.
Now, we will be using LMTD method for this particular part of calculations to obtain the values we need. Time to calculate. Rate of heat transfer, Q, is equal to percentage of reductions times heat produced from the reactor, and from this, it will give us a value of 115.5 megawatt. To find the value of delta TLM, it can be done by calculating the values of delta T1 and T2 and substituting it into the delta TLM equation, which will then equals to 42.055 degrees C. To get the value of correction factor F, we just need to calculate the value of P and R and get the value for F from the graph of correction factor of the LMTD method. To find the surface area, it can be done by plugging in all the variables of the delta TLM equation and solve for AS. And lastly, the number of tubes of the heat exchanger can be calculated by inserting the values of the variables from the equation of calculating the area, which results in the value of 4,124 number of tubes.
Well, it seems like we have reached to the end of the video. We hope you like it and thank you for watching.